My name is Brian Fraser. I'm a senior lecturer at SFU in computing science. I teach in the Surrey faculty in the Surrey campus in the software systems program. So some of the core topics in our software engineering program are kind of not just how to write code or how to make it work, but how to make the code better. And so a big idea is you don't just want to have it working for today, you want to have it working for the next 10 years. And you want the next person who comes along, which is actually probably going to be you in 3 years, to look at the code and go, hey, I know what's going on here, I know how to improve this, I know how to work with it. So I spend a lot of time helping students not just write code, but write good code. And so they can then have a clean structure, and it's easy to change, it's easy to make it do new things for them, and that really helps them over time. One thing I really like in my courses is that I try to prepare students for having practical skills that they're going to need when they start to maybe do their own projects, or in industry when they try to start to do bigger things. So I did work in industry as an embedded developer, and so I'm teaching the embedded systems course. And for that, we thought, well, how do we want to do that? And so we came up with the idea of using some actual hardware. And so students now, instead of buying a textbook, they buy this piece of hardware, and it's got a little board on the bottom, a BeagleBone, and they can control that. It runs Linux, and we built this custom board on top, which we call the ZenCape, that will allow students to interact with a bunch of different components. The big idea is that now when they finish my course, they've really got all these practical skills that they can apply on co-op or when they get a full-time job as a kind of a junior software embedded engineer. And that's really, really helpful. I've got a number of messages from students who've done this in the past, and like, wow, this really gave me those skills that I needed that first year on the job. It really helped me kind of hit the ground running. In the embedded systems course, I was looking at designing the course initially and thinking, well, what level am I going to teach? And I went and I looked at engineering, and I looked at a number of other faculties and the things that they taught, and I decided, well, really, our students come in with a really strong basis in software. And so I'm going to teach students to be really strong with the software as it interacts with the hardware. And so we built the board, and we say, okay, you can buy this off of us, and then you don't have to do much hardware design. It's all there, it's wired up, and it's not going to be problematic. And so students can right off the bat get lights to flash, you can press a button and it does something. And I make this big show and lecture about like, look, a light is flashing, it's amazing! And everyone thinks I'm crazy. And then they go home and they spend 4 hours installing software and configuring a VM and doing all these things that I need them to have those skills. And they get the light to flash, and they're like, yeah! It's an amazing kind of like, I spent the week getting a light to flash, and none of their friends know why unless they've taken my course. And so that's, I think, a really valuable part. They do get to use other components, and so they can use this, for example, it's a distance sensor, ultrasonic distance sensor, and they can incorporate all that into different projects that they come up with. And they get that opportunity to wire it up, to connect to other things, but that's not really the focus. I really want them to sort of say, well, I can now work with an engineer or a software or hardware designer, and I can apply all of my software skills to really make that hardware sing and dance.